Hi students, so welcome back to Brainiacs online sessions. So today we are going to see the change in momentum, okay, of the body which is undergoing projectile motion, okay, and the change in velocity will cause change in kinetic energy. The change in height will cause some changes in potential energy. So all those things we will analyze today. Okay, say suppose if a body is undergoing projectile motion, okay, this is projected with the velocity u, making an angle theta with the horizontal. Okay, so at the highest point, that is at the maximum height, this will have only one component of velocity. Suppose if we resolve this initial velocity u, we will be getting u cos theta along horizontal direction and u sin theta in vertical direction. So at the topmost position we have u cos theta only. Its vertical component Vy will be what? 0. Already we have discussed all these. At the lowermost point we will have again u cos theta as the horizontal component, and the same u sin theta will come here, okay, but in the opposite direction. U sin theta. Clear? U cos theta, u sin theta, u cos theta, u cos theta, u sin theta in the downward direction. Now suppose if I write all these 3-point velocities, okay, initial position, highest position, final position, I am putting those names, okay. Initial position means not here after projecting, just after projecting, okay. This is just before touching the ground, so this can be considered as final position, and this is nothing but highest position, right? Now I shall write all these velocities in vector form for proper clarity, okay, so that it is easy for us to change the velocities, change in momentum, all that. This u cos theta is in which direction? X direction. So the unit vector associated with the x direction is I. So I am going to write u cos theta I plus, this is in y direction, so the unit vector associated with the y direction is j, so I am writing u sin theta j. So u vector is actually this one. If I write the velocity here, this is nothing but velocity at the highest point is equal to what? U cos theta I again. Same way the velocity at the final point, so here instead of writing this also we can write, but I can write better velocity at the initial point I can write. So when our velocity at the final point is u cos theta I, what? Minus u sin theta j. So is it clear? Do you have any objection in writing like this? Okay, just we have wrote the informations with the complete details, okay, magnitude, direction, everything. Clear? Fine. Now if we write change in velocity between highest point and initial point, the velocity between highest point and initial point, I can write that velocity at the highest point minus velocity at the initial point, I can say. So what is this? I can write velocity at the highest point is first the final destination, then initial destination. So highest point is what? U cos theta I minus initial point is U cos theta I plus U sin theta j. Okay, so this is what is the highest point velocity, initial point velocity. Right, so what can we write here? So this is equal to this thing and this thing will be cancelled off. I can write minus, okay, j into U sin theta. So the change in velocity between this point and this point will be what? Minus ju sin theta. Now, what about change in momentum? What is momentum? Momentum you have studied in laws of motion, which is nothing but quality of a motion. What is quality of a motion? Quality of motion means how much effect it is going to make if it hits something. Mass into velocity. If mass is more, the impact will be more. If velocity is more, the impact is more. Okay. Even a bus or train, even if it is coming and hitting us, okay, with a moderate speed also, it will affect us. A thing as small as bullet, if it comes with such immense velocity, it will affect us. So momentum is mass into velocity. Change in momentum is what? Mass into change in velocity. Change in momentum is mass into change in velocity, because in this kind of motion, mass will not change. Mass will change if a body travels almost equal to or near to equal to the velocity of light. Then only mass will change. Mass will change. Mass is not always constant. Mass can change if something travels of the order of velocity of light. Velocity of light is 3 into 10 raised to 8. So suppose if it is traveling at like 10 raised to 7 or 10 raised to 6, such velocities, then there will be some change in the mass. But in these kind of things, mass is constant. So change in momentum is nothing but mass into change in velocity. So the change in momentum between highest point and initial point is nothing but mass into change in velocity between highest point and initial point. So I can write minus j into mu sin theta, minus j into mu sin theta. Okay, so this momentum is a vector. So change in momentum is a vector. So that is why here also that j comes. Clear? So you need not by heart this equation. But at least we should know how to take the values if they ask a question. Okay. Just simply put the direction of velocity and magnitude of velocity, direction of velocity, magnitude of velocity. Take the difference into mass. Bus. That is what change in momentum. Note it down. Right. Now this is change in momentum between highest point and initial point. Okay. Now we will consider the change in momentum between initial point and final point. Okay. Initial position and final position. Okay, so velocity at the initial position is equal to u cos theta I plus u sin theta j. Clear? Alright, so change in velocity between final position and initial position. So this is nothing but velocity at the final position minus velocity at initial position. Final position is that. So u cos theta I minus u sin theta j. So this is the velocity at the final position minus the initial position. So that is u cos theta I plus u sin theta j. If we expand this, u cos theta I minus u sine theta j minus u cos theta I minus u sine theta j. So this u cos theta I and u cos theta I will be cancelled off. We will be getting minus 2u sine theta j. Minus 2u sine theta j. This is the change in velocity between final point and initial point. Okay, so suppose if we write change in momentum, okay, change in momentum between final point and initial point. So this is nothing but mass into change in velocity between final point and initial point, or final position and initial position. So m into, so this is nothing but minus j into 2 mu sine theta, minus j into 2 mu sine theta. So this is the change in momentum. Momentum is vector, and so velocity is vector. Okay, this is vector. Okay, so we have got direction also along with this. Clear? Okay, see children, now we will do some questions based on this. Okay, so read the question. Okay, a body of mass 0.5 kilogram, a body of mass 0.5 kilogram is projected under gravity with a speed of 98 meter per second at an angle of 30 degree with the horizontal. The change in momentum of the body, okay, between final position and initial position. Okay, so they have given mass is equal to how much? 0.5 kilogram. Then it is projected with a speed that is 98 meter per second at an angle theta is equal to 30 degree. Okay, what is the change in momentum? So change in momentum, delta P is equal to minus j into 2 mu sine theta. Okay, just if you forgot that, okay, just take it. This is nothing but u cos theta I minus u sine theta j. Here the velocity is u cos theta I plus u sine theta j. So this minus this means here minus will come, here also minus will come, this will be cancelled off. So minus 2 u sine theta j. Change in momentum, so if we add m also, if we multiply m also, 2 mu sine theta j. So you can very fastly you will be able to take the values. Projectile need not be always like this. Different types of projectile is there. So how to deal all that we will see shortly in the next session. You need not worry about that. All these things are approaches. Okay, we need not by heart it. Just understand and apply. Okay, after applying so many times in the problems, sometimes certain formulas will be in your memory. So those things you can directly smash. Right. So minus j into 2 into mass is 0.5, u is 98, and this is equal to sine 30. So sine 30 is what? 1 by 2. So 2 can be cancelled off. So 0.5 is what? 1 by 2. 1 by 2 into 98 is 98's half. So which is 49. Okay, 49 kilogram meter per second. So this is the change in momentum. Okay, this is the change in momentum. Okay, fine. So in the option they have given Newton second, that unit is also correct. Newton second is also fine, or otherwise kilogram into meter per second, that is also fine. So this is the answer, option B. Clear? Shall we move to next question? So the concepts in physics, okay, whatever general concepts in physics, that will come in projectile motion. Okay, sometimes electrostatic concepts can come, work power energy concepts can come. Okay, so each of the thing, if you practice separately in projectile motion, then whatever question they ask based on this, you will be able to judge. Okay, so that is why separately we have seen them. Okay, another question, question number 2. I will read it. Question number 2. A particle of mass 100 gram, a particle of mass 100 gram is fired with a velocity of 20 meter per second. Fired with a velocity of 20 meter per second. Okay, at an angle of 30 degree with the horizontal. 30 degree with the horizontal. Okay. When it rises to the highest point of its path, then the change in momentum. Very easy, already we know. Okay, so here they are asking the change in momentum between highest point and initial point. Already we have seen the change in momentum is equal to minus j mu sine theta. Okay, between initial and final is minus 2 mu sine theta. Here this is nothing but minus j mu sine theta. So minus j into mass is 100 into 10 raised to minus 3. Okay, to convert it to SI unit, into velocity is 20, and this is going to be sine 30. So sine 30 is 1 by 2. If we cancel this and this, we will be getting 10. Okay, so this is going to be 1 Newton second, because this here, this 10, everything will get cancelled off. So 1 Newton second or 1 kilogram meter per second. That is the answer for this question. Okay, so option D. Okay, option D. 1 Newton second. Here we have got the options as 1 kilogram meter per second, whatever it may be. Both are units of momentum. Clear? Understood? Okay. Third question. Okay, shall I read? Okay, two equal masses are projected at the same angle theta from 2 points separated by their range with equal velocities. So everything is same. Okay, everything is same. Okay, same mass, same angle, and with the same initial velocities. So the question is the momentum at the point of their collision. Momentum at the point of their collision. Options are given. Okay, so all these questions, just pause the screen and try to do yourself. Okay, then we will see what answer you are getting. Okay, so this third question, what answer you are getting? Okay, so suppose okay, they are separated by their range. So this is projected at an angle theta, this is also projected at an angle theta. So obviously what will happen? Okay, they are going to meet and they will be colliding at exactly same distance. Okay, exactly same distance only, because angle is same, initial velocity is same. Okay, all these things are same. Okay, their masses are same. Okay, so then they are asking what is the change in momentum. So what is the change in momentum of both? Okay, the question is, okay, change in momentum, the momentum at the point of their collision. Okay, the momentum at the point of their collision, that is the momentum of the system they are asking. Momentum of the system they are asking. Suppose if one mass is moving like this, its momentum is nothing but mv. Okay, suppose if this is A, same mass. Okay, so momentum of PA is mv. Another mass, same mass. Okay, but another body, if it is moving like this, okay, its momentum is what? Minus mv in the opposite direction. So the question is the momentum of the system. okay, or the momentum generally of these things. So this is nothing but mv minus mb. Okay, since they are vectors, we need to add vectorially, but thing is they are equal and opposite, so simply if we take a sign, things will be done. So the answer is 0. Now there is a concept called angular momentum. Already you might have studied about momentum. Okay, momentum we know, even in the lower classes also we have studied momentum P is equal to mv. So what is angular momentum? Okay, in plus one physics, angular momentum will come in rotational motion. Okay, so in rotational motion, angular momentum will come, but motion in a plane comes before rotational motion, so we cannot wait till that. So what we will do, whatever concepts which are necessary that can come here, we will study that and we will proceed. Okay, in detail about this you will study in rotational motion. Okay, so momentum P is equal to mb. Momentum P is equal to mb. Angular momentum is actually r cross p. Angular momentum, this momentum, linear momentum is denoted as p. Angular momentum is denoted as L. L is r cross p. R cross p. This is also called moment of momentum. Moment of momentum, or we can say the rotational effect of momentum. Okay, rotational effect of momentum. Just like in the linear case, we will be getting force. Force is equal to ma. Force is equal to mass into acceleration. Same way here we get torque. So torque is nothing but the rotational effect of force. Suppose something is connected here. If we push this, this will have rotational motion. So this is having rotational motion, just like a door. So we say torque is what? R cross F. This is called the moment of force. Moment of force. Moment of force. Okay, moment of force. What is this R? Suppose you can see this is connected here, just like a door. Okay, door is connected here. We can apply force also, force here also in order to open this. We can apply force here also in order to open this. We can apply force here also to open this. It is very difficult. How much length is there, that much comfortable we are, because the rotational effect is more. Torque is more if this R is more. R is nothing but this perpendicular distance. Same way this R is also just like this, a perpendicular distance. So torque is nothing but this distance R into the force which we are applying. Okay, the angle between perpendicular distance and force is 90 degree. Suppose if the force is acting like this, we will take this component of force. In this case, we will study all these things in rotational motion. But just for comparison, I was telling to force, torque, linear momentum, angular momentum. So everything related to circular motion, rotational motion, we will take the analogy from linear motion. Whatever concepts are there in linear motion, we will take its equivalent, we will apply in rotational motion. Okay, so same way this momentum will have this rotational, okay, substitute or counterpart in this rotational motion. So momentum, angular momentum. Angular momentum, the formula is R cross P. What is this R cross P? Everything we will see now. Suppose here this is a point of observation. Point of observation. Something is moving like this. A body or something is moving like this. Okay, something is moving like this. Suppose at this position its velocity is v. This is a point P. Now what is this angular momentum? We will take this distance okay, so this is a point P. At this instant velocity of this body is, a body is moving here, okay, a body is moving like this. Okay, so this is the point of observation O. Now this distance is nothing but r. Okay, now the velocity is in this direction. Velocity is in this direction. Okay, so already we have studied about cross product. So taking cross product, this L is equal to r, magnitude of r, magnitude of P, and sine theta, we can say. What is this theta? Theta is the, see, this is the direction of r. This is the direction of r. So how we will take the angle? Theta is the angle between r vector and p vector. R vector and p vector. Theta is the angle between r vector and p vector. So the direction of r is this. So what we will do, in order to take the direction, we will extend this to show the direction. Magnitude is only up to this. Then we will take this theta. Okay. So r sine theta means see, if we r sine theta means either if we want we can resolve this and directly we can take like this component. Okay, I will show that also. So now you can understand that angular momentum is r, which is the distance from the origin, from wherever we are observing. So that distance into the momentum in this direction, whichever direction velocity, that is the direction of momentum. And this is nothing but the angle between this r vector and momentum. Okay, so I hope you understood. Now, so this is one kind of explanation. Another kind of explanation is same way this is moving. Now if this is the point of observation, okay, till this is what is r vector. Simply we are extending in order to understand the theta. This is the direction of velocity. Now suppose if I resolve this vector into two components, okay, this r vector, instead of r vector, this okay, this is the r vector. So if I take r vector, if I resolve this r vector into vertical direction and horizontal direction, I am showing here, that's it. If I want I can show here also in order to avoid confusion. Okay, so this theta is what? So here, in order to get this from origin or from the point of observation, if r is the distance, we can take r sine theta into p. See, r cross p we cannot change the order. Okay, r cross p we cannot change the order because this is cross product. Once we have taken r p sine theta, so this is just a magnitude. This is magnitude, the magnitude of r into magnitude of p into sine theta. So we can change the order also, no problem, but this includes the direction also, so we cannot change the order in this form. So if I take r sine theta here, this is actually this distance, it's perpendicular component. See, if this is theta, this is actually the direction of r vector, or we can say that this is actually the unit vector. Okay, this is indicating the direction of r vector. So this r is r cap. Okay, this is r cap. Now if I put theta here, this theta will come here also. So I can draw like, I will resolve this. This is actually what? r sine theta, and this is actually r cos theta. So if we need, we can write this is nothing but the perpendicular component of this r. So if we want, we can write in this way also. L is equal to angular momentum is equal to r perpendicular p, bas, this is enough. Okay, so in this way we can take the perpendicular component of v also. Okay, but I am not getting into the details of all that. But how, you know how to take the angular momentum. If the particle is here, draw a line from the origin. So this distance cross this velocity, or the perpendicular component of this into mv. Okay, likewise we can take. Okay, so this is the fundamentals of angular momentum. These fundamentals I have discussed just to do a problem in projectile. Okay, we will see that. Clear? Okay, so thing is like angular momentum is nothing but r cross linear momentum, or we can say rp, the magnitude of r, magnitude of p into sine theta, or otherwise r perpendicular into the linear momentum. But if we want, we can write like this also. Okay, now we will see question number 4. Okay, a particle of mass m is projected with a velocity v, making an angle 45 degree with the horizontal. Okay, the magnitude of angular momentum of the particle about the point of projection when the particle is at a maximum height. Okay, so easy. Okay, so this is the projectile. So the angular momentum at this point, this is what we need to find, angular momentum at this point, and this is the point of projection. Already while discussing the angular momentum, we have seen, like with respect to some observer or with respect to some observation point, we need to find angular momentum. So that observation point is this. Okay, right. So now this is projected at an angle 45 degree, projected at an angle 45 degree, and what we need to find? We need to find the angular momentum here. So this distance is what is r vector, and what is the velocity here? This velocity we know, this is nothing but u cos theta. This projectile is projected at an angle v. This is projected at an angle v. Okay, that also we know. So now we need to find the angular momentum of the particle about the point of projection when it is at a maximum height. So here if we consider this height, okay, see the formula for angular momentum is either we can do r cross p. What was another formula? The perpendicular distance into p. So this is r cross p. This is the magnitude of perpendicular distance into magnitude of this linear momentum. Then sine theta we need not write because this contains sine theta. This is actually what? Magnitude of r into magnitude of p into what? Sine theta. So this r and sine theta, all of them putting together only this thing. What is this perpendicular distance? If this is the distance, its perpendicular component, see, this is the r perpendicular, the perpendicular component of this thing, which is same as this maximum height, See, whatever be this thing, this is same as the maximum height. So this angular momentum is equal to r perpendicular into linear momentum. So r perpendicular is nothing but maximum height into mass into the velocity here. This is what is linear momentum. So u cos theta. Right, now this is projected with the velocity v, so we will replace this with the v itself. So what is the formula for maximum height? U square sine square theta divided by 2g. U square sine square theta divided by 2g. So u square is nothing but v square, and sine square 45. So this angle is 45. Sine square 45 divided by 2g into mass into v cos theta. So v cos 45. Clear? So what we have is mv cube v square mv cube divided by 2g. Let's write. What is sine square 45? Sine 45 is 1 by root 2. So sine square 45 we can write as 1 by 2. 1 by 2. Cos 45 is what? Again 1 by root 2. 1 by root 2. So considering all this 2 and 2 if we consider, that will become 4. So the angular momentum is nothing but mv cube divided by 4. This root 2 we will take and g. So this is the answer for this question. mv cube divided by 4 root 2 into g. So option B is the correct answer. Okay, clear? Fine. Now you read this question. Fifth question. A projectile is projected with the kinetic energy k. Okay, so a projectile is projected with the kinetic energy k. So here the kinetic energy is k. Okay, its range is r. Its range is r. It will have minimum kinetic energy after covering a horizontal distance equal to. It will have minimum kinetic energy after covering a horizontal distance equal to. If you know this concept, things are easy. Okay, otherwise we may land up in mistakes. So okay, the minimum kinetic energy, where we are going to have minimum kinetic energy. Okay, minimum kinetic energy. Here also total energy is kinetic energy. Here also total energy is kinetic energy. Where maximum potential energy is possible at this height, here only we are going to have minimum kinetic energy. That is at a distance 0.5 r. Okay, at a horizontal distance 0.5 r we will have minimum kinetic energy. Clear? Hope you understood. Okay, now sixth question. A projectile is fired at 30 degree with the momentum a projectile is fired at 30 degree with momentum p. Neglecting friction, the change in kinetic energy when it returns to the ground will be. Okay, what is the answer for that? Okay, a projectile is fired at 30 degree with the momentum p. Neglecting friction, the change in kinetic energy when it returns to the ground will be. Okay, see, if the kinetic energy here it is k, then here what? It is again going to be k. Okay, it doesn't matter whatever be the direction. Kinetic energy or energy is generally scalar. So the answer is 0. Okay, answer is 0. There won't be any change in kinetic energy. Okay, next question 7. Question number 7. Okay, question number 7. A particle is projected making angle 45 degree with the horizontal, having kinetic energy k. Okay, having kinetic energy k. A particle is projected at an angle 45 degree 45 degree with a horizontal having kinetic energy K. The kinetic energy at the highest point. What is the kinetic energy at the highest point? What formula we have studied? This is going to be K, whatever be the energy, K naught cos square theta. K naught cos square theta. So this is going to be, the initial kinetic energy is given as K. So instead of K naught we will take K, and cos square 45. So K into 1 by root 2 the whole square, simply we can say K by 2. Okay, so the answer is K by 2, half of the kinetic energy. Clear? So remember this one, so that we will be able to connect it easily. Clear? Now eighth question. Two balls of same mass are projected, one vertically upwards, the other at an angle 60 degree with the vertical. The ratio of their potential energy at the highest point. Okay. So, okay, eighth question. A particle, two balls, okay, 5, 6, 7, eighth question. Two balls of same mass, okay, one is projected exactly upwards, okay, and the other is projected at an angle 60 degree with the vertical. 60 degree with the vertical. See, you have to be very careful about this. All our formulas in projectile motion are based on this angle, that is the angle with respect to horizontal. So if they give some angle, don't put that angle and proceed. Okay, be very specific and clear. This angle, if this is 60, then this angle is going to be 30 degree. Okay, so this is the angle which we need to consider, because every formula we have taken that one, so we have to be careful. So that is the point given in the question. Okay, ratio of their potential energy at the highest point. So what is the formula for ratio of what is the formula for potential energy at the highest point? See, K naught sine square theta. What is K naught? K naught is half mu square, we can take like that, or otherwise initial kinetic energy, or nothing but total energy, whatever it may be. Okay, right. So the question they are asking is the ratio of their potential energy at the highest point. Okay, right, ratio of their potential energy. So two angles are there, one is at 90 degree, the other one is at 30 degree, not 60 degree, actually 30 degree. 60 degree is this one, but we need to consider 30 degree. Okay, so the potential energy which is projected, the potential energy of that mass which is projected at 90 degree is nothing but, okay, K naught into sine square 90. Okay, divide by potential energy of that mass which is projected at 30 degree is equal to K naught into, I'm sorry, here we need to write K naught into how much? 90 degree. This is 90 degree, so this is 90 degree. Okay, this formula. Now K naught into sine 30 degree, sine square. So K naught can be cancelled off. Sine 90 is 1, so 1 divided by sine 30 is how much? 1 by 2. So its square we will have to take. So definitely this 2 square will go outside, 4:1. So the ratio is going to be 4:1. Okay, so this is also a projectile, but projected at 90 degree. Okay, so we need not worry about all that. Clear? Okay, question number 9 is okay, in the above problem, okay, the problem which we have seen just above, kinetic energy at the highest point for the second ball is K. Okay, what is the kinetic energy of the first ball? Okay, or the kinetic energy of the ball which is projected at 90 degree. Okay, so if we project like this kinetic energy here in this case will not be equal to 0. But the problem is, if we directly project at an angle 90 degree, here the kinetic energy formula, even if we apply, we will be getting like k naught cos square theta. So actually k naught cos square 90 degree we will have to put. So this will become 0. So kinetic energy of the ball which is projected directly upwards, that will be 0, because that will have a dead stop at the topmost point. It will not have this motion or this motion. It will not have this motion also. But projected like this, then definitely it will have at least horizontal component of velocity. So that is the reason projected exactly upward will have 0 kinetic energy. Clear? Done. Question number 10 now. Question number 10. A ball is thrown at an angle 0 with the horizontal. Its initial kinetic energy is 100 joule and it becomes 30 joule at the highest point. What is the angle of projection? Okay, so the question is, question number 10. A ball is projected at an angle theta. Okay, and its initial kinetic energy is, that is kinetic energy at origin is nothing but 100 joule. This is actually total energy. And kinetic energy at the highest point, okay, kinetic energy at the highest point, we can write like this is nothing but k naught cos square theta is equal to how much? 30 joule. What is the angle of projection they are asking? What is the angle of projection? Okay, so this 100 we will substitute here. So 100 into cos square theta is equal to 30. We can write cos square theta is equal to 3 by 10. And we can write cos theta is equal to root 3 by 10. So theta is nothing but cos inverse root 3 by 10. So that is how the options are also given. So we can take like that. Clear? Fine. Okay children, so I think you understood like how to take the change in momentum, change in velocity, how to deal with the angular momentum, then kinetic energy, potential energy of a projectile. Okay, so practice more, try to practice more problems of this type. Okay, keep focusing on the subject. Okay, thank you, goodbye, good luck.